Hello students, welcome back to my class. Today, in today's lesson, I am going to explain a theorem. This theorem is in 10th standard, SSLC 10th standard, part 1 mathematics related, geometry, and it is on circles. Subject is mathematics for class 10, topic is theorem on circles. We have a theorem. Actually, there are two theorems in this chapter. This is the first, 4.1. In this theorem, the theorem says, the statement is, the tangent at any point of a circle is perpendicular to the radius. The terms that are present in this statement are tangent, which you know already, a line which touches the circle at one point is called tangent. So here xy is tangent. Xy is tangent, right? And another thing, word perpendicular is used. Word perpendicular when two lines cut each other at 90 degree. The two lines are called perpendicular. When two lines cut each other at 90 degrees. These two lines are called perpendicular lines. And another word used here is radius. You already know that distance from center to the circumference is radius. So here OP is radius. What does the statement say? Tangent xy at any point of a circle. This is tangent at point P of the circle. P is a common point. P is a point on the circle and P is also a point on the line xy. So P is point of contact where the line, tangent and the circle meet each other, cut each other, intersect each other. This point is point of contact. So xy is tangent, OP is radius. And the statement says that tangent is always perpendicular to the radius at the point of contact. So at point of contact, the tangent and the radius, they are perpendicular to each other. They make 90 degrees. This we have to prove. And there is not much calculation or there are not many steps in this theorem. It is very simple. You can write the answer of this theorem in words. Theory part is there, lot of theory part is there. But to understand that theory part, which is already there in your reader, to understand, we have to understand this. I have already drawn another line here. A line is drawn and there is a point here. If you observe carefully, I have marked some of the points of the line. There are so many points on the line. There is a point here, point here, point here. So many indefinite number of points are there. Uncountable number of points are there on this line. But I have marked some points. I have darkened some points on this line. I have made them dark. Right now, here is a point. What if I join this point with this point? Right? If I join this point and this point, this is distance. Distance between this point and this point of the line, right? And if you observe carefully, an angle is formed here. This side, the angle formed is, of course, more than 90 degree. It's an obtuse angle. And an angle is formed this side also, which is acute, less than 90 degree, right? This side we are getting obtuse angle more than 90. This here. Now, if I join this point, to this point, then what would happen? Let's see. I'm joining these 2 points now. Now, what happened? what happened? This, if you observe carefully, this distance is more and this distance is less compared to this line. This line is shorter and angle is also decreasing here. This obtuse angle, it was obtuse angle here, also obtuse angle, but the amount decreased, and this side acute angle and it is increasing. Now what if I join this with this? Now what happened? Again the distance, this distance became shorter. So as we are moving this side, this distance is slowly decreasing, and this obtuse angle more than 90 is also decreasing in amount, right? Forget this acute angle. This is obtuse, it was very big, then it became smaller than this. Now it is smaller than this. Now what if I join this one? What if I join this line with this line? This point. The distance still decreased and the angle became here 90 degree. It was more than 90 here. So it is decreasing. And we know that a time will, and this length is also decreasing. So a point comes where the distance becomes the shortest and the angle becomes, it was more than 90, decreased, so more than 90 decreasing. Imagine it was 100, then became 95, then became 92. Now that there will be a point where it will become equal to 90 degree and the distance will be shorter. And if we go beyond that, if we move this side, then what will happen? This distance will again increase, and the angle here also increases, and this side angle decreases. So what does it mean? It means from this point, the points on the line are joined, right? Now the point which is at shortest distance, that will definitely make 90 degree. The point which is at the shortest distance, this distance is more, this distance is less than that, this distance is less than that, and a time will come, a point will come where the distance is becoming the shortest, because if we move this side again, the distance is again increasing, and angle is again this side decreasing and this side increasing. So this is the shortest distance. The same thing is happening here. Look at this line. If I take a point here, and join the center with this point, then what will happen? This distance is more than this, and the angle also formed here, angle formed is more than 90 obtuse. As we move this side, the distance will become shorter and shorter, and angle will also start decreasing. At a point, this point of contact, where the circle and the line have a common point, this is the shortest distance. Of course, clearly this is the shortest distance. And what happened to the angle? Angle will become equal to 90 degree. From a point, if the points on a line are joined, then the shortest distance will have 90 degree. The same thing is happening here. This is the shortest distance between center and the line. This is the line which is tangent to the circle, and if I join center to any point on the line, then the shortest distance is here. If I join here, it will be smaller than this. If I join here, that will be smaller, still smaller. If I go here, then that will increase. It will become more than OP, right? So OP is the shortest distance. If OP is the shortest distance, then the angle between OP and XY must be equal to 90 degree. This is the proof. This is how we prove. And it's all theory. It's there in the reader. The theoretical part is there in the reader. You just have to write that theory part. How it became equal to 90 degree. So from this we come to know that, angle between radius and tangent at the point of contact will always be 90 degree. If it is 90 degree, then we can say that tangent and this radius are perpendicular to each other. If I draw a radius here, imagine this radius is OQ is the radius, and if we draw a tangent that passes through Q, then this line, imagine this line is MN, if this line is MN, then angle between MN and OQ will definitely be equal to 90 degree, and therefore OQ and MN at the point of contact it is 90 degree, so OQ and MN are perpendicular to each other. This is the theorem. Theory part you have to learn from your reader, is there on page number 97. Part 1 reader, page number 97, Theorem 4.1. Learn it well, practice, and I hope you all understood the lesson. And in our next class, we will discuss the second theorem. We will discuss some questions based on this theorem, and we will also discuss 4.2 theorem. Thank you. Do subscribe our channel. Thanks.